Hello algebra students. So today we're looking at slope, and the word slope is used to describe the measurement of steepness of a straight line. The slope is a rate of change. So when we're looking at the steepness of a line, when we're graphing that, it's a relationship, and that relationship is a rate of change. So slope, steepness, rate of change, those are all the same thing. We use the term rise over run to describe slope because it is the vertical change over the horizontal change. So vertical change, rise, over horizontal change, run. And then to calculate slope, we use this formula. M is the letter that we use to stand for slope in an equation. And so you'll see that most of the time that M equals slope. And to do that, we calculate the vertical change, that's that rise, with a y2 minus y1 over x, those are the horizontal values, x2 minus x1. And those are not exponents. Those little numbers are not exponents. They're just talking about like the second point and the first point. So you'd have 2 points to calculate slope, 2 points like in an ordered pair, x comma y, and you take the second y value minus the first y value over the second x value minus the first x value. Now in the first example, we have the graph of the line and 2 points marked on the line. And we can use that graph to find the slope when we think about it in terms of rise over run. So that's really how far does it go up versus how far does it go over. And how you would check that is you would just pick 2 points on the line. Now we've picked these two already. And you want to pick 2 that are easy. So you pick 2 that fall right on like the crossing points of a line. So you won't see us picking something like halfway in a box. You know, you're going to pick it on a corner. And then you really can just kind of count your way to do, okay, what is the rise? How many up? 1, 2, 3. So that's looking at 3 for the rise, and then how many over, and that's over at 2. So 1, 2, and so the rise over run is 3 over 2, and so the slope is 3 over 2. Now this is slanting in a left to right direction going upward, so that is a positive slope. So again, as you can see, this line is going upward from left to right. And so we always look at the direction from left to right, and going upward in the direction from left to right is positive. And so we have a slope of a positive 3/2. And that is an improper fraction, but we don't write slope as a mixed number. We would always leave it as that improper fraction so that it would be a relationship of rise over run. So you don't want to write it as a mixed number. So in the second graph, again, we pick 2 points if we're trying to find the slope from that, and we pick 2 points on an intersection. So you do want to pick where they're kind of crossing the corners of squares. You don't want something in the middle. And so we picked 2 points here. We've picked what would be 2, 3, and 3, 0. So picking those 2 points. And let's just take a look at those points. That would be 2, 3, and 3, 0. Again, just picking them on the corner is really what you're looking for there. And then we're counting the rise over the run. And so we want to look at how much do I go up versus how much do I go over. Now here my first point is 2, 3. So in the rise, I'm actually going downward. So I would just count that, and I'd go 1, 2, 3 downward. And then I'm going over 1. And you can look at that in this relationship as well. The difference in my y values is 3, and the difference in my x values is 1. And so that slope is 3 over 1, or you can just write it as 3 but that slope is going downward, and so that is a negative 3. So sloping downward from left to right is negative. So in the next example, we want to use, we're going to draw a graph of the line and then find the slope of the line. We're going to use the formula for this one. The m is equal to the y sub 2 minus y sub 1 over x sub 2 over x sub 1. So first let's just draw the graph of the line. We've got 2 points. We just need 2 points to make a graph. So we're going to graph -2, -4, and 1, 5. And whenever we don't have like a scale on the grid, then we can assume that it's a 1-to-1, so that each block would count for 1. And you're, on the horizontal axis, on the x-axis, your negatives are always going to go to the left of the y-axis and the positives to the right. And on your y-axis, the positives go up and the negatives go down. So if we're looking at -2, -4, so that means we would count over -2 and up to -4. And so that's where that point would be. Oh, no, I'm sorry, that's incorrect. -2, -4, 1, 2, 1, 2, 3, 4. So over to -2, down to -4. And then 1, 5 would be +1 across to the right one, up 5. So 1, 1, 2, 3, 4, 5. And then you want to draw your line. Let's see how well I can do this on the stylus there. Not fabulous, but probably easier on paper. And then you have that graph of line, and we can see that that line is sloping upwards, so we should get a positive slope. If we don't, that's kind of a way to check that we're doing things correctly. And in relationship to the formula, we want to look at the 2 ordered pairs a little closer. So focusing in on those ordered pairs, we have our x1 and our y1. Now remember, those are not exponents. It's just like, okay, that's the x from the first point and the y from the first point. And then we have x sub 2 and y sub 2. So x from the second point, y from the second point. And we would go over to the formula and plug those values in. So we have our m is equal to, and we take our second y value, which is 5, and then the formula says to subtract, and we subtract our first y value, which was -4. Now notice it's minus -4, and then that's over x, so our sub 2, so we take our second x value, which was 1, and we subtract our first x value, which was -2. And, when you go through and do the arithmetic for that, if you want to change your subtractions to adding the opposite, you can. You, of course, don't have to do that. You would get the same value. But what you get is that m is equal to 9 over 3, which is 3. So the slope is 3. So on the next example, we're just going to practice that. We're going to plot a graph of a line and then find the slope. And so we have the point -2, 2. Let's see if I can graph this one correctly the first time. So we're going -2, so to the left 2, +2, up 2. And so there's our first point. And then our second point is 6, -2. So I'm going across to the right, 6. And down 2. And there's our second point. And then we just connect those two to make a line as straight as we can. And then we can use those that graph, and we can use the formula to find our slope. So again, looking at those ordered pairs where we have our first x value and our first y values, and then we have our second x value and our second y value. And so we can take a look and just remind ourselves of the formula. This is a formula that you do want to memorize. So you want to make sure you're kind of practicing that. So it is m, which stands for slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And again, that is a formula for slope that you do want to memorize. It's fairly important, both in algebra algebra 2, etc. So, and extremely important when we're doing linear equations. And then we can do our plug-in. So we get m is equal to, and we take our second y value, which is -2, and we subtract our first y value, which was 2, and all of that goes over our second x value, which is 6, and we would subtract our first x value, which is -2. And again, you could go through the arithmetic for that. If you want to change your subtractions to adding the opposite, you can. And then you get m is equal to, in the top we get -4, and in the denominator we get 8. And now that reduces. We do always want to simplify if we can, just not simplifying to a mixed number, keep it as a fraction always. And this one, of course, is just a regular fraction, and that simplifies to -1/2. Now, what that amounts to in the relationship, because remember that slope is a relationship of steepness, is that slope tells us several things. The negative tells us that the line should be going down, which is good because that's what our line was doing. And it says that for every down 1, we are going over 2. And then, so we can come back to our graph and say, okay, is that what's happening? Are we going down 1 over 2? Yep, back on the line. Down 1 over 2, and I'm back on the line. Down 1 over 2, I'm back on the line. Down 1 over 2, back on the line. And that could go on forever on that line. And so that is what that slope is telling us, that each time we go down 1 over 2 to find the next point, we end up back on that line. So as with most everything we do, there are some special cases that come up. So I'm going to show you one of those here. First, we're going to graph our 2 points, and we've got -3, 2. So 1, 2, 3 to the left, and then up 2. And we have -3, -5. So across to -3, and then down -5. So there's our point, and a little easier to draw this line because it's nicely following the grid. And we want to consider our formula. So we're looking at, okay, that is our first x value and our first y value and our second x value and our second y value. Now, honestly, the order of those does not matter. You could have the second point be first and the first point be second, and you're still going to get the same relationship in the end. So don't worry about if you happen to switch those up. And then we want to take a look at, use the same points in the formula to check our answer. Let's find our slope here. So we have m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, writing that because partly we want to make sure that we have that memorized. And then we can plug in our values. So our second y value is -5. And we subtract our first y value, which is 2. And that goes all over our second x value, which is -3. And we're subtracting our first x value, which is also -3. And then doing that arithmetic, we get -7 over 0. Now that is an issue. We can't divide by 0. If you try and do that in your calculator, you're going to get 0 error or just an error. Because when we divide by 0, that is what we call undefined. Or what we term as no slope. Okay, and we'll take a look at the notes on that. So a horizontal line has a slope of 0, and a vertical line, which is what we just had there, has no slope or undefined. Now there is a little short mnemonic that we will work with more later when we're dealing with equations, but I'm going to show it to you now just so you've seen it. Maybe it'll stick in your head there, that we use, and it's, let me write that the other way. Hoi VUX, which doesn't stand for much right now, but basically what that tells you is a horizontal line has a 0 slope, that's the 0, and the equation is y equals. We haven't looked at equations really, but we will get to them. And then here a vertical line has an undefined slope, which is that's that no slope. And that equation is an x equal 2 line. So just putting that out there, and we will use it more later. Hopefully it'll stick in your brain. All right, so looking at number 5 is kind of taking the information that we've already had and applying it in a little bit of a new way, where we have the point and a slope. Now we'll deal with point slope form. That applies to writing equations of lines, so we want to make note of that here, okay, we have a point and we have a slope. So previously we needed 2 points to make a line, but we also could make a line if we have a point and the slope. So we're going to draw that first point, which is 0, 5. So I'm just going to, I'm starting my origin. I'm going across 0 and up to 5. 1, 2, 3, 4, 5. And so that's where my first point would be. And their slope is the slope of -3. Now the negative tells me that I'm going downward. So let's just take a look at that off to the side. So -3, the negative says go down. And then the 3 tells me to go down 3 units. So that's units downward. And then as far as the over, that's where when we have a whole number or an integer, you can always put that over 1. So that means you would go across 1. And so that's telling us from any point on the line, we can go down 3 over 1 and end up back on the line. So we can go down 3. Let me grab a different color here. Down 3, 1, 2, 3, and over 1. And that's where we would end up back on the line. So I'm going to put another dot there. Then, okay, from there we can go down 3 over 1. And that's where we would end up back on the line. So I can put a dot there. And that can continue. Down 3 over 1. And I would be back on the line. And so from those dots that are on the line, we can create a graph of the whole line. Then we can look at the next example. So let's look at number 5, letter B. And again, we're going to draw the line that passes through a point, and we have a slope. So we have a point slope form here. And this time, we're going to put a point at -2, -4. So -2, 1, 2, 3, 4. -2, -4. And our slope of 2/3, I'm going to look at that off to the side there, tells me to go up 2, because it's positive, and over 3. And because we're always looking at the relationship from left to right, we're always talking about going over to the right, or I will always be talking about going over to the right. So up 2 to the right 3. So again, I'm going to grab a different color here. And from the point I already had, -2, -4, I'm going to go up 2 over 3. And that would put me back on the line. And so, according to that slope, so that's where my next point would be. And then from there, I can go up 2 over 3. Now, you really only have to do 2, but it's always a good idea to make sure they're lining up, and then you can connect those to create your line. Please remember to take any questions into your algebra teacher and ask, ask, ask. I hope you had a good Thanksgiving break, and I guess we'll be back when you see this. Have a good one.